MCQ 8 is a relationship towards a chapter of chemical bonding, whereby we are looking, in this case of the question, similar three-dimensional arrangement of their atoms. Alright, so the items that was listed out here includes diamond. We have silicon dioxide, which is very much on layman known as the structure of sand. We do have our graphite. And lastly, iodine. So to mention here first, diamond, graphite, as well as silicon dioxide or sand are considered to be giant covalent compounds. But in the case here for iodine, although it contains your covalent bond, is in that of your simple covalent compound, or some might actually refer to it as a simple covalent molecule. They are actually the same meaning over here. So just start off first with iodine. It's a diatomic molecule. So within both iodine atoms inside, I would say that it contains your covalent bond. I will just use green to indicate your strong covalent bonds here. However, as a simple covalent compound, we do not exist as a singular molecule, but we exist as multiple molecules itself. Now, all these multiple molecules, similarly, they contain the strong covalent bond, but what is found between them, they are actually bonded using our weak intermolecular forces of attraction. So again, another way to describe the weak intermolecular forces of attraction could be using the term van der Waals forces of attraction. But now let's take a look at diamond as well, graphite as sand, the giant covalent compound. Starting off with graphite, they exist as hexagonal carbon ring layers. So these hexagonal carbon ring layers, within the layer, they are actually bonded by your strong covalent bonds. But the interaction between the layers comes using your weak intermolecular forces of attraction, and this actually attributes to graphite's ability to act as a lubricant because the layers can actually slide over each other. Now, diamond and sand here is actually the answer for this question here because they have what we call as a tetrahedral configuration. In this tetrahedral configuration, you will see that, in this case, starting for diamond first, one of the carbon atoms is actually bonded to 4 other carbon atoms. And this tetrahedral structure in diamond actually gives rise to its apparent rigidity. Alright, it's considered to be one of the naturally strongest items that you can actually find in nature itself. Now, silicon dioxide, on the other hand, also consists of silicon attached to your oxygen in a similar manner as well, also in a tetrahedral configuration. Alright, so again, we should be saying that the similar three-dimensional arrangement will be for the case of diamond as well as silicon dioxide, which is otherwise known as sand. Okay, going again with the whole idea of its tetrahedral configuration.